Dr. Murthy, I just realized that the threshold function we learned about in the previous video is discontinuous, unlike a linear function. Is this a problem at all?
Initially, during the initial days of Perceptron, this was a popular activation. But this is not a very good activation. Why is that? What is it saying? Hey, if y is less than or equal to 0, it is 0. And y is greater than 0, it is 1. Now, the problem with this is at that 0, this function is not smooth. Um, you see, there is an abrupt change between 0 and 1. At that value, this is -3, -2, like that. It's good, -2, etc. But at 0, suddenly something happens and y value goes up. Right? 1, 2, 3. So that's the problem. And in general, you will see that we are going to do some differentiations, etc., to learn these W1, W2. We'll see that in the next classes. But to do differentiation, you need a smooth function. If by the way, to follow this course, you need to know a bit of matrix algebra, at least just multiplication of matrices, and a bit of calculus, derivatives. If you are not comfortable with these two, I'm not going to cover them. So just, Khan Academy or some of the wonderful resources you have, just brush up. And again, these are not really complicated things I'm going to do. Very basic matrix multiplications, one-dimensional or two-dimensional derivatives, very simple stuff. Okay, but one of the very first things that we know about derivative is when there is an abrupt change like this, and when the function is not smooth like this, hey, you know what? At that point, computing the slope or derivative or what they call gradient is very, very difficult. Well, it is not definable. You have to make some approximations and all that, which we can do, but that's why this last sheen, this particular function, threshold function, lost the sheen.
If the threshold function is not always useful, are there other activation functions?
A couple of other functions became popular. And those functions, actually, I think it may be better if I show them on the web. One of the functions is called sigmoid function. So as you can see, the sigmoid function here, it looks weird. It really looks weird. 1 over 1 plus e power minus x, but it's pretty cute actually. And see, if x is equal to minus infinity, minus of minus infinity is infinity. So e power infinity is infinity. 1 over infinity is 0. So if x is equal to minus infinity, it goes to 0. If x is equal to plus infinity, e power minus infinity, which is 0, 1 by 1 plus 0, which is 1. So at x is equal to infinity, it touches 1. Asymptotically, it goes all the way to 1. Here, asymptotically, it goes all the way to 0. So sigmoid function, like threshold function, varies between 0 and 1 only. But it's a lot more system. It's smooth. You see, nowhere it abruptly jumps from 0 to 1. It goes slowly from 0 to 1. And in fact, in most places, it is 1. In most places on this side, it is 0. And some small region, -6 to 6, is where it takes significant non-zero values. Okay, so, and at 0, where x is equal to 0, e power 0 is 1, 1 by 1 plus 1, 0.5. So at 0, it's 0.5. So one way to activate my y is substitute in the So whatever I get, x1 w1 plus x2 w2 plus x3 w3, I put that in this thing. And depending on the value, if it's a high negative value, it will be 0. High positive value, it will be 1. Somewhere in between, it will be some value between 0 and 1. So the good news here is this automatically translates our structure into a nice classification problem. So let us let's see if this allows for this cut and paste things. Oh, not bad. Okay, so this is our sigmoid function. So this activation with sigmoid is a very popular way. So I do the exact same thing, then I activate with sigmoid. So the way I have to now learn my weights is the weight should be learned such that when I give x1, x2, x3 of a zero class, whatever I coded as zero, the y should be after activation, the value should be sigmoid of y should be 0. For the one class, the weight should be such that if I learn x1, x2, x3, if I provide x1, x2, x3, the sigmoid of y should be 1. So this is the beauty of neural networks. With more or less the same construction, you can solve regression, classification, a variety of problems very easily.
That is true. Both regression and classification involve the perceptron, representation of a graph, and activation functions, which just happens to be the unity function for regression. Thank you for teaching us these elegant AI solutions, Dr. Murthy.